Maize is the number one staple crop now in Nigeria.
Maize is a very important crop in the world, more particularly in Africa.
Sai muna fuskantar matsaloli da dama. Na farko akwai wata ƙwaruwa wadda take ƙasa wanda ake ce magwa.
Pests pose a major constraint to production and productivity of maize. Insect pests and drought are one of the key challenges, apart from soil fertility, trigger,
Maize, also known as corn, is a staple delight in many parts of the world. In Nigeria, it is one of the most important crops for food, livelihood and economic growth. When boiled or roasted, maize is a popular snack across the country, providing a go-to meal to keep one going and income for millions of households. Maize can be milled into flour and cooked as a local delicacy known as tuwo in northern Nigeria. It is also the major ingredient for many processed foods including cornflakes, golden morn, and cerelac for babies. But that's not all. Maize is an important constituent in poultry feeds due to its nutritional value. Known as TELA Maize in the science world, maize is rich in carbohydrate, protein, fat, vitamins, minerals, and water. It is also used in industries for the production of maize syrup, biofuel, starch processing, and grain alcohol around the world. But the story of maize begins on the farm. As the second largest producer in Africa, Nigeria produced 11.5 million metric tons of maize in 2020. However, the country is still yet to meet local demand, which is currently around 18 million metric tons. This is primarily due to low yield per hectare brought about by several factors. Mustapha Abubakar has his fair share of troubles.
Indeed, we face a lot of challenges with regards to pests and diseases. First and foremost, there is this insect inside the group that eats deeply into our crops, even after your crop has reached harvest stage. Then there is another one that damages the heart of the crop, that makes us to spray or else we'll lose everything. Then the last one is the one that drains the water in the maize and stops it from producing yield. I do not really know the names of the pests, but they are really dangerous to our crops.
Compared to South Africa, which produces over 5 tons of maize per hectare, Nigeria has a meager average of 1.6 tons per hectare. This means unless science is adopted, Nigeria will need at least 3 hectares to produce the same amount of maize that South Africa produces on one. Pests and diseases are a major problem for maize farmers in the country. Sesamia calamistis, also known as the pod borer and the fall army worm, are 2 major enemies of the maize plant, eating up the leaves and the stalk until there is no nutrient left to sustain the plant or produce maize. On the other hand, it is the issue of drought, especially in the drylands and savanna regions of the country. As a foremost agricultural research institute in Nigeria, the Institute for Agricultural Research in Samaru, Zaria, has taken up the challenge to bring respite to maize farmers. Armed with the right personnel and facility, the institute is at the forefront of a revolution of one of Nigeria's most important crops.
Maize is the #1 staple crop now in Nigeria, which means it provides food for close to the half of the Nigerian population, if not more, which is in the range of around 120 million or thereabout. So maize is very important as a staple crop. Shortage of maize supply in this country will translate into very serious food crisis.
To avert such a crisis, the IAR has continued to develop technologies to boost productivity.
#1 is the productivity per se itself, how much production you can harvest or potentially from each hectare that a farmer plants. This productivity has increased from just barely 1 ton per hectare previously in the last 30-40 years to the current position of up to 8 metric tons per hectare. So varieties with high productivity has been developed by our scientists. This is #1, pecking the potential productivity.
Riding on the successes of the past, the Institute introduced the TELA Maize project in Nigeria in 2019 in collaboration with the African Agricultural Technology Foundation (AATF) and with support from the Bill and Melinda Gates Foundation and USAID. Derived from the Latin word tutela, which means protection, the TELA project focuses on 2 central materials: the drought-tolerant maize and insect-resistant varieties.
More than 100 kilogram of maize is consumed annually per person. So it's a very important crop, a very important food for food security in Africa. People are not too familiar with this technology. What we are saying is this: the drought, the one that are genetically modified or GMO, which we call TELA, having insect protection trait or gene in them, these materials, how they were developed, might be interesting to people to understand, because often people ask, oh, they are GM, they are not safe, but sincerely, they are the safest varieties or crop you can think about worldwide.
Cereals program leader at the Institute, Professor Rabiu Adamu, is at the confined field trial farm for routine inspection. At this field, the TELA materials, protected with the Bacillus thuringiensis BT gene, a soil-based bacterium, are planted side by side the regular materials. The result is clear for all to see.
Genetically modified with the BT gene, that is Bacillus thuringiensis gene, to compare resistance to it against fall armyworm and stem borers. If you look at it side by side with this that is not transformed, you could see that it is clearly damaged compared to these leaves. So this is what we are demonstrating. This damage is what we call fall armyworm signature damage. This trial is drought trial. Some of the materials are also genetically modified. You can see this one and this one are the same material. Okay. One is having the gene, like this one, to enable it to tolerate moisture stress.
The drought-tolerant material as well is showing great signs of tolerance, having been starved water since after the first 6 weeks of cultivation, as against the regular materials that are looking pale, stunted and unlikely to survive. The third category is the optimum yield variety.
Before now, drought has been a militating factor, especially in the drier Sudan and Sahelian zone of Nigeria. Farmers lose their crop due to the end of season drought. If they don't plant early and the rains extend up to October, most farmers will not be able to realize a good yield. So they are lost up to 40 to 50% due to drought. For insect pests, it's another big challenge. Prior to 2015, the major insect pests were the stem borers. Anywhere you plant maize, stem borers used to attack the crop, and it could cause up to 80% yield loss. Additionally, we have a new pest, the fall armyworm, that comes into the country in 2015. This pest also causes high devastation to farmers' crop. It can cause up to 80% yield loss, which translates into almost 260 million naira in the last 2 years.
But what exactly does this project portend for farmers in the country?
First of all, is to popularize high-yielding varieties of maize that are transgenic, that is, that are genetically modified to tackle the issues of droughts and stem borers and fall armyworm. These two constraints, if not controlled or managed, could result into more than 80% yield loss. So that is one. Two, we want to make available high-yielding varieties of maize to African farmers. These varieties that we are breeding, they have yielded the varieties that we have now. So they have a yield advantage of almost 80% compared to our common hybrids that are in the markets. And three, to popularize these crops that are having high grain quality. We have observed that grain quality is an issue in Nigeria. These varieties have better grain quality than the existing varieties that we are growing.
To ensure the efficiency of the pest-resistant material, the Institute set up an insect-rearing laboratory to artificially breed the insects of concern, the stem borer and the fall armyworm, in a bid to have sufficient population to infest the maize plants on the field. This is a tedious and careful process that takes weeks. The laboratory technician Hamza Adamu explains the process of sourcing and rearing the larvae into full-grown adult insects.
What we do here is, first of all, we go to the field, scout for insects, adults, collect them from the field, bring them to the lab, clean them, and then put them in artificial diet so that they will develop from larva to adult. If they develop to adult, then we provide cages for them. Put the adults into cages, put feed inside the cages, and then make it in such a way in which they are going to be roaming about, and then the mating will take place in the cage between the male and female of the insect.
The female insects go on to lay eggs on improvised objects in the cage. The eggs are collected and catered for until maturity. On the field, these insects feed on plants and other organisms. Here, a special diet is prepared for them.
Well, you know, in the lab, you have to get artificial diet. There are a combination of some ingredients in which you have to get carbohydrate, fat, vitamin, and some of them, then you add them just to copy what they eat in the field. In the field, they eat on the leaves. So we also get some of the leaves in the field and then dry them here in the lab, grind them, and then get small quantity and then add it to the other ingredient so that it seems as if it is the exact food they find in the field. The quantity is 75.6 grams. So I have to get exactly 75.6 so it's properly. warm water. You add it.
A fully matured larva is taken to the field to bombard the plants. The difference between the BT genetically modified materials and the regular hybrid is very clear in terms of resistance.
We are in the third phase of the CFT trial. So the third phase is actually, the experiment was conducted without any problem that we have encountered during the earlier phases. So like during the rainy season, we infected the plant with stem borer, but the infestation was not severe due to rain. So because as you have excess rain, it will kill the larva of the stem borer. So the infestation was not that severe. But presently during this dry season, the infestation was severe and we are able to see clear differences.
There are 16 hybrids currently being evaluated for pest resistance. With regards to economic gains, both on the micro and macro levels, the future is promising.
These varieties, the transgenic will give us up to 8 tons per hectare. So what I'm saying is that there is 50% yield advantage if you grow transgenic materials that are protected against stem borers and fall armyworm to compare to non-transgenic. That is a very good yield. If you can get 50% higher than what we are getting with the same environment, the same pest, it's a very good progress.
This also means that maize farmers won't need to spend so much money on pesticides, thereby reducing cost of production, which will increase their profit as well as the safety of the maize. The current practice in the country sees farmers spray pesticides on their maize plant between 4 and 6 times before harvest within a single farming cycle. With the variety being developed, spraying may only be required once, if at all needed. Once given the nod by the National Biosafety Management Agency, this trial will be taken out of confinement and replicated in other areas and farms across the country to test their performance. For an experiment that involves genetic modification like the TELA Maize project, it is important to adhere to global guidelines and regulations to ensure that science prevails at all times. As the regulatory lead of the project insists, standards have been maintained all through. Another issue that stirs controversy is that of safety.
Like any other genetically modified crops, right from the laboratory stage, there are procedures that are put in place to ensure that these materials are safe before they are being released. Let's say in the case of the TELA Maize, the gene that is inserted is a BT gene. How safe it is this BT gene? Scientifically, it has been established that the BT gene is safe because the BT gene is gotten from the microorganism Bacillus thuringiensis, which is a soil-borne microorganisms. And in fact, as children, one time or the other, when we're playing outside, we ingest soil. So there is no way you can say that the BT gene is not safe. The other gene that is inserted, which is Bacillus subtilis, this is a gene that is commonly found in our locust bean that is fermented. So we all eat the locust bean known as dawa, the fermented version, and it contains this particular gene. So it is safe for consumption.
The way they were developed to take care of all issues related to safety. Safety to environment, safety to human, safety to animals. For any food crop or food that has passed through regulatory scrutiny and has been approved are considered safe to eat. So issue of safety, let's forget about it. This has been mentioned by the World Health Organization, the Food and Agricultural Organization, the European Food and Safety Authority, and
Strict standards of confined trials are also strictly adhered to by the IAR. Nothing is taken out of the field during such trials due to the need to prevent infiltration into the market. All through the process, from planting through the vegetative stage and fruiting, the IAR has continued to implement the TELA Maize project with utmost transparency. Field visits and invitational tours were organized at different points for regulatory bodies like the Biosafety Management Agency and the National Agricultural Seeds Council, as well as farmer groups, commissioners of agriculture from several states, and seeds companies from all parts of the country.
This one will continue to receive the water until physiological maturity. It's only drought where we have stopped irrigating drought. So we want to impose drought for flowering and grain filling, which is the most critical stages that you can see the effect of drought.
This stage is the vegetative level, and the heat is very important to our farmers. So we look at it together when it's time for the yield, so that we'll be able to see what we have seen now, does it translate to it? But as a matter of fact, what we have seen today is that they are resistant to the resistance to drought, and the stem borer is a thing that is actually working.
As you can see here is one of the efforts being put to saying, okay, the farmer should be able to get adequate or the seed required to sustain them, to get economic yield that will sustain them and their family.
Although naysayers continue to oppose the use of science to improve agriculture, there is yet no evidence across the world that biological genetic modification of crops is harmful to humans. As for the TELA Maize, farmers across the country can start getting these improved seeds from the second quarter of 2022 once all approvals are granted.
I will want to call on Nigerians, especially our farmer colleagues, to be very open to embrace new technologies and new interventions that come along as a result of new government policies. These policies and the new technologies that are being adopted are nothing but geared towards improving our total productivity as a country, and also to increase their revenue from agriculture.
Dawn has come for maize farmers across the nation. The goal for the IAR is to get the TELA Maize seeds to at least 35% of farmers in Nigeria by 2025 and achieve full adoption by 2030. The future is bright. Not only will Nigeria bridge its deficit of almost 6 million metric tons, but the country will become the largest producer of maize in Africa and a major player in the global ecosystem with sufficient and premium quality maize.